Modern society runs on energy mostly from oil and other fossil fuels. But when burned, these materials produce an unwanted byproduct, carbon dioxide. Smokestack and tailpipe exhaust bolster the natural insulating layer of atmospheric gas that keeps Earth warm. In the last 150 years, trillions of tons of CO2 created by industrial activities have heated Earth up by about an extra 2 degrees Fahrenheit. How much hotter might it get? That depends in part on the future of a band of forest that encircles the Earth at the equator. This tropical jungle absorbs huge amounts of the CO2 that we release before it can accumulate in the atmosphere. Surprisingly, some scientists say that the forest's ability to absorb CO2 depends on what happens to tropical vines.
So we have a series of projects, and they're all interrelated. For example, we're trying to explain the distribution of vines across local, regional, and global scales.
Biologist Stefan Schnitzer is taking me to his unusual experiment in the jungle of Panama.
Let's go into plot 7. See what it looks like.
He's a leading expert on the class of vines that grows woody stems, the kind Tarzan swings on, known as lianas.
If you look at this one, this is a twiner. When it touches something, it senses that, and the cells on the outside start elongating more, so it makes it curve. And that's what this is looking for. It's looking for a trellis.
Not long ago, a research team noted that vines in the Amazon were becoming more abundant, far outcompeting trees. The scientists found that the amount of vine, wood, and leaves had doubled in 20 years. Schnitzer hopes to learn why and whether the trend will continue. The answer matters. Lianas absorb and store much less CO2 than the trees they displace.
A liana this big has a huge amount of leaves up in the canopy. They can displace trees, but they themselves are not going to sequester the carbon that they displace in trees, and that's what we've shown.
We're almost at the plot where Schnitzer made this discovery.
Well, this is the corner of the plot. If you look around here, there's something you notice about this forest.
No lianas.
Aha! So we cut lianas out of this plot in 2011.
After Schnitzer and a machete-wielding team cleared away every vine here, they tagged and measured the diameter of every tree. With this census, and another they subsequently took, Schnitzer tallied up how much carbon was stored in wood and leaves in vine-free jungle compared to that of normal viney control areas. He'd predicted that, freed from shading and strangling vines, trees in liana-free plots would grow vigorously. Since trees support their crowns with sturdy trunks and lianas don't, Schnitzer anticipated that his experimental plots would increasingly contain more carbon than the controls.
So we found that to be true. In fact, the effect was much stronger than we had anticipated.
Schnitzer and several colleagues reported in 2015 that vine-choked control areas absorb an amazing 75% less carbon per year than liana-free tracts. The dramatic findings suggest that when lianas grow better, forests soak up less CO2 from the atmosphere.
Tropical forests that are dominated by vines store very little carbon compared to forests with lower vine abundance.
This effect could hinder a critical mechanism for slowing the pace of global warming. Schnitzer is beginning experiments to determine why lianas are becoming more abundant. Scientists have proposed many explanations.
Carbon dioxide levels in the atmosphere are going up quite a bit. That could explain what we see.
Some research has cast doubt on the CO2 theory, but the case remains open. Schnitzer hopes he can settle the matter with a series of trials.
We're going to expose them to different watering treatments, stronger droughts,
higher temperatures, and even different light levels.
So we think we can really get a handle on what's driving the relative abundance and what could be causing their increases relative to trees and tropical forests.